Uh, Hello, this is Haozhu. Let me introduce this lab of the part one, uh, milestone one Q-learning math silver. Um, in this part, I implemented a classical Q-learning agent to solve an by math using Python. Um, the environment is 6 by 6 grade. The start position is 00. The goal is 5 5, and the 10% of the sales are randomly set as votes. The agent can take 4 actions: up, down, left, and right. And if it hits a wall or goes out of the bound, it stays in place and receives a reward of minus 10. And each normal moves cost -1. The receiving the goals gives plus 100. And the Q table has a dimension of n by m, for which means each state has 4 action values. And I initialized the Q table with random values between minus 0.1 and 0.1. And during the training, I used the rate alpha 0.1 and a discount vector factor gamma 0.9. The agent used Epson grid policy, uh, which um, epsilon linear decays from 0.9 to 0.1 over the first five 500 episodes. And in total, I trained for 1,000 episodes, each with a maximum of 1,000 steps. Um, and the training, oh, um, okay. This is a training reward curve. The blue line shows the reward for each episode, and the orange one is the orange line is the moving average over 25 episodes. As we can see, the rewards increases steadily and stabilize after around 300 episodes, indicates that the agent has learned a good policy. And this is the result. Okay, thank you.
Step 2. Describe our milestone 2 in the lab9. At first, we create a maze. We build an M-grade maze and we start in the 0, 0, and our goal is n-1 and m-1. And in our grid, we can find 0 means empty, 1 means wall, and 2 means goals. We also create walls in these areas. We create the random walls in maybe 10% of the maze. And then in these steps, we can find 0 means up, 1 means down, 2 means left, and 3 means right. When we achieve the was like is greater ing equal to 1, we just reward minus 10, or we out of our maze we also return the minus 10. And when we achieve our goals, we return the 100. And anything else, we just return the minus 1 and our next step. This is our step. And then we create a robot. In this robot, we can find the learning rate is how fast Q table values are updated, and the future factor rate is that how much future rewards are discounted. Because our robot may focus on the current time or focus on the future time. We use episode and actions, these two functions, to find the robot. The goal by itself, like go up, go down, go left, go right randomly, or just look at the Q table in its hand and to find the right ways. Q table are stored many ways and that has a high reward. We also can update this Q table by these areas. Then we train our milestone 1 and we return our reward. We also store the good trends in the data set for the future training. And you can find we store many data sets, like the many good traits. And we pre-training this with the history, and we can use the history in the training milestone 2. And we can also evaluate and compare this milestone 1 and milestone 2 by the picture. And you can find these areas. In the milestone 1, it has some total reward up, down, up, down, up, down very quickly. But for the milestone 2, it uses history from milestone 1. It can get the result and the total reward don't have minus, or just has a little bit minus number. Okay, thank you very much.
Hello, I am Yuli Zhu. This is the demo video for part 3 of lab9, which is the deep Q network version of solving the maze, which is maze 3. Different to the Q table method, here I use a neural network to approximate the Q values. It has 2 hidden layers of 64 neurons with ReLU and a dropout layer of 0.3 to prevent the overfitting. Here's the train function, and I use the experience relay with a buffer of 1000. The batch size is 32 and the Adam optimizer, and also the Huber loss. Epsilon decays from 0.9 to 0.1 over maybe 500 episodes, and in every 10 episodes I will freeze the target network to stabilize the learning. Here I ran the training on my MacBook Pro using my Apple GPU through the MPS backend. You can see here's a running each episode and printing average rewards and losses. Here's the reward curve. It rises quickly during the first 200. It rises quickly during the first 200 episodes and then stabilizes. The final success rate is 100%, with an average of 18 steps to reach the goal. So this DQN achieved the same final performance as the Q-table versions, but it's smoother and more stable, and scales better for larger mazes. Thank you very much.